Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2023, paper 6, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Beth completes some jigsaw puzzles and records the following information: the number of pieces in the jigsaw puzzle and the time to complete the jigsaw puzzle in minutes. Beth shows this information in a scatter diagram. So we've got the scatter diagram. You can see number of jigsaw puzzle pieces along the bottom and time taken to complete the puzzle up the side. So each cross, I guess, is a jigsaw puzzle, isn't it? How many pieces versus how long it took to complete. Question A, part 1 says Beth completes 2 more jigsaw puzzles, a 3,000 piece jigsaw puzzle taking 460 minutes and a 1,300 piece jigsaw puzzle taking 320 minutes. Show this information on the scatter diagram. Okay, so we've got 2 more points to plot. So reading up from 3,000, then we're going to have to put a point in at 460. Now, I can see that there are 5 little divisions between 400 and 500. So each one of those divisions is going to be 100 divided by 5, which is 20. So we're going to have to go 3 little squares up from 400 to get to 460 then in that case. So 400, 20, 40, 60 is going to be there. So it's just above that point that's already there. So that's one of them. And the other one is at 1,300 and 320. So this time I need to work out how far along this bottom scale to go. So there are 10 divisions between 1,000 and 2,000. So a gap of 1,000, and we've got 10 units to span it. So 1,000 divided by 10, each one of those little squares is 100. So 3 little squares would be 1,300. So I'm going to go 3 squares along from 100 and then up to, well, I get up to 320. So that's 1 little square above 300. So I'm going to have a point like that. Okay, right, so they seem to fit in the overall pattern for this scatter graph then, isn't it? Part 2 says describe the type of correlation shown on the scatter diagram. Well, you can see reading this graph from left to right, the graph is kind of sloping upwards, so you can see they're all kind of lying under this ruler going up in this bar from left to right, apart from this point over here. We'll probably come to that one in a minute, no doubt. I'll leave it for now. So yeah, but all the other ones are in a quite a strong positive correlation then. So I'm going to say the correlation is positive. Positive is sloping up from left to right. Negative would be going the other way. It would be going down from left to right. Okay, but this one is clearly positive. One of Beth's jigsaw puzzles was described as the most difficult jigsaw puzzle you will ever try. Circle the most likely jigsaw puzzle on the scatter diagram. Well, I think I've already done that, haven't I? It's that outlier up there. It's got a few number of pieces, but it took forever to do. It took over 700 minutes to complete, which is much longer than all the others. So I'm going to assume that that one was the killer jigsaw puzzle. I've already circled it, so that's good. I was lucky. And then part 2 says, give a reason why you chose this jigsaw puzzle. I'm going to say it is an outlier. and I'm going to say that it took much longer to complete. Draw a line of best fit on your scatter diagram. Okay, so I'm going to ignore the outlier. Now you can see that if I put my ruler like that, it kind of captures all the points underneath it. Can you see them all under there? So then if I just come down a little bit and then draw my line, so I've kind of got the same number on both sides, then I think that would be a reasonably good line of best fit. So mine's going to go up like that. Now it's not an exact science, and if yours doesn't lie exactly the same as mine, I wouldn't overly worry about it. You usually have a certain tolerance, and it's quite wide on these sort of things. As long as it's kind of sloping upwards vaguely along with the points, you should be fine. And it says use your line of best fit to estimate how many pieces are in a jigsaw puzzle that take Beth 500 minutes to complete. Okay, so we're going to find 500 minutes on the minutes axis, which is here, look. And I'm going to read across to my graph and then change directions and read down. So across to the line, the best fit that I found. I'm going to spin round and go down to the other axis and read off my mark down there, look. And I can see that's 2 little squares beyond 3,000. Now each one of those squares, remember, was 100. So I'm reading that as 3,200. Now your answer will be marked against your graph. So it's a good idea to show your method like I've done like that with the line. Make it nice and clear to the examiner what you did. And yeah, don't worry if yours is different from mine. If you've looked up the right number from your line of best fit, then it's right for you. Then finally, explain why Beth should not use her scatter diagram to estimate how long it would take to complete a jigsaw puzzle containing 8,000 pieces. That would be beyond the range of data. I.e. extrapolating. Which is unreliable. Okay, so I've said beyond the range of our given data. In other words, it's extrapolating, which is unreliable. Okay, I think that's good enough remark. Question 2. A restaurant menu has 4 main courses and 3 side dishes. For their meal, each customer chooses 1 main course and 1 side dish. Work out the percentage of possible meals that cost less than £8. Right, now, in order to work out this, we're going to have to know the total number of combinations there are. So that's going to be the number on the denominator of our fraction. And we're also going to have to know the number of combinations that cost less than £8. Okay, so they're the 2 things I need to know. So the total combinations that's going to be equal to, so I've got 4 choices for main course and I've got 3 choices for the side dish. So then altogether I've got 4 times 3, which is 12 choices then, haven't I? Right, now what about combinations that cost less than £8? Okay, so let's just go through these carefully. I could have a beef burger, that costs £6. So if I have £6 and I want it to cost less than £8, then I could have the garlic bread, and then that would be £7 in altogether, wouldn't it? So that would be okay. But that's the only combination, because if I have the salad, which is the next most expensive, that's already £8 and it has to be less than £8. If I have the lasagna, then I can't then make it cost less than £8 because if I get the garlic bread, that's £8 already, and that's the cheapest one. So that isn't an option. I could get the veggie burger, that's quite cheap, that's £5. I could have the veggie burger salad, that would be 5 plus 2, that's £7. I could have the veggie burger and chips would not work, that would be £8 already, but I could have the veggie burger and the garlic bread, and that is £6. And then what else have we got? Turkey stew, which is £6. Can't have the salad, that'd be 8. Can't have the chips, that'd be 9. But I could have the garlic bread, that would be 7 then, wouldn't it? So I've got 1, 2, 3, 4 choices which are less than £8. Percentage less than £8. That's going to be the number of dishes that were below £8, which is 4, divided by the total number of dishes, which is 12. Now that's not so handy, that's a third. What's that as a percentage? Okay, well it's going to be, if you divide 1 by 3 on your calculator, you're going to get 0.3 reoccurring, aren't you? And then that as a decimal is going to be 33.3 reoccurring percent then, isn't it? Okay, we're going to times that through by 100. So that's going to be 33.3 reoccurring. Question 3, write these numbers in order of size, starting with the smallest. Okay, so we've got a motley collection of different numbers here, all in different formats. How are we going to compare them? Well, I suppose we need to get them all into a similar format. I think probably the best thing to do is just write them all as decimals, and then we can easily compare them, can't we? So 0.36%, if I divide that by 100, I'm going to get 0.0036% there. That's what that one is as a decimal. What's 1 over 333 as a decimal? I might just type that into my calculator. 1 divided by 333, written as a decimal. That's 0.00300, and then 003. It's reoccurring, isn't it, that 003? I think I can forget about the rest of it. Now the next one is already as a decimal, and then I've got 3.1 times 10 to the minus 3. So when I've got a number in standard form like that with a negative index, I just kind of write that number of zeros down. So 3 zeros, 0.00, and then I'm going to write the mantis apart on the end. So then I'm going to write 3, 1. Okay? So they're all my numbers. So which is the smallest one? Now, if you find this hard to compare because they're decimals, you can just try and pad them out so they've each got the same number of digits, and then you can just think of them as numbers then. So then you've got 36, 30, 331. You might find that an easy way to compare them. So anyway, I can see that my smallest one is that fraction then. It's going to be the 1/333. That's the smallest one. Next biggest is going to be the number in standard form, 3.1 times 10 to the minus 3. That's the next largest. And then we've got the 36%, 0.36%. That's the next biggest. And finally, the biggest one is going to be the 0.03, then, isn't it? It's much bigger than the other ones. Question 4. Casey's mobile phone gives a weekly report showing the amount of time they use their phone. This week, the report says that the phone was used for 217 minutes, which was 24% more than last week. Calculate Casey's phone usage last week. Okay, so I like to do percentages with a triangle like this, final, original, multiplier, and then I just think about what I've been given, which of those 3 things I've been given from the question. So have I been given the final? Yes, I have. That's the final there, isn't it? So that's what it was this week. The original was last week, and that's the one we're trying to find, isn't it? Calculate Casey's phone usage last week. So to sort out between the original and final, you just need to think about the tense, present, past. So the final is in the present tense, and the original is in the past tense in this case. Okay, so I know that that one is the one I want to find, and the final is 217. I know that the multiplier then, what's the multiplier? It's 24% more than last week. Okay, so it's an increase of 24%. So if we start with 100% and we add on 24%, then now we've got 124%, which as a decimal is 1.24. Okay, so that is the amount I'm going to be using, 1.24. Okay, so then once I've worked out all my values, I just cover up the thing I want to find, in this case I'm going to find the original. So that tells me then that the original is equal to the final divided by the multiplier. Okay, which is 217 divided by 1.24. So I'm just going to type that into my calculator. 217 divided by 1.24. That's reassuringly whole number-ish. That comes out to be 175. Okay, so then the number of minutes last week was 175. it's increased by 24% and it's now gone up to 217. Does that make sense? Yeah, I would expect if it's increased then it was smaller to start with. So just have a think about, does my answer make sense before you move on with these sorts of questions, because it's easily to get, get these muddled up and to pick the wrong final and original. Okay, but mine's looking good. I'm moving on. Question 5, a sheet of A4 card weighs 1.19 times 10 to the minus 2 kilograms. Work out the weight of 500 sheets of A4 card. So in order to work this out, then this is a multiplication thing, isn't it? It's going to be, if each one weighs 1.19 times 10 to the minus 2, and I've got 500 of them, then it's going to be 500 times as much. So the total weight is going to be 500 lots of 1.19 times 10 to the minus 2 then, isn't it? Okay, now I could convert it and all that sort of stuff, but I don't really need to, because I've got a button on my calculator that does standard form, so I'm just going to type it in and let the calculator take the strain. So I'm going to do 500 times 1.19, and then I'm going to press the times 10 to the X button down here, look, and then I'm going to put in the power, which in this case is -2. Right, so it's looking like it does on the page. Pressing equals, that comes out to be 5.95. 5.95. I would just say that before you type anything in your calculator, though, just write it down on the page so you get credit for it if you mistype it or whatever into the calculator. I'm pretty confident I got that right. It's 5.95. Part B says card is classified using W, the weight in grams per square meter, or GSM of the paper. That's a real thing. So W is weight in grams divided by the area in square meters. It's a bit like a compound unit, this one, isn't it? Like density. It's got, or pressure, something like that, where it's got the unit is made up of two other units. So a sheet of A4 card is a rectangle that is 21 centimeters by 29.7 centimeters. Calculate W for this A4 card. Okay, so let's work that out then. So first off, we need to know what the area is, so I can put that in the bottom of my equation. So the area of a rectangle is just length times width. Now remember, when you're working in compound units, you need to make sure all your units match up. So I'm aiming for grams per square meter here, and my area measurements are given in centimeters. So actually, I'm going to have to convert them into meters first, aren't I, if I want to work in grams per square meter. So 21 centimeters, that's the same thing as 0.21 meters, and 29.7 centimeters, that's the same as 0.297 meters. So if I convert them now into meters, then my area is going to then be in square meters, and then it's going to be easier to work out grams per square meter later. So 0.21 times 0.297. Obviously it means we're going to have to be dealing with equal decimals though, but I think that's going to be easier than converting meters later. So 0.297, so that comes out to be 0.06237. Okay, so that's the area of this sheet of paper in square meters. Next thing we need to work out is the weight in grams of one sheet of card. So what's the weight going to be? Now again, we were given the weight earlier. It was 1.19 times 10 to the minus 2 kilograms. But I'm aiming to get this measurement in GSM, which is in grams. So I'm going to have to convert that kilogram weight into grams. So again, I'm just going to use the calculator to work that out for me. So I'm going to do 1,000, because there are 1,000 grams in a kilogram, times 1.19 times 10 to the minus 2. So what's that then? 1,000 times 1.19 times 10 to the minus 2. I suppose I could have just written 1,000 as 10 to the 3 and combined it with a 10 to the minus 2. That would have also worked. But that comes out to be 11.9. Okay? So it's 11.9 grams. Okay, so my weight is now in grams and my area is in square meters. So now I'm ready to work out grams per square meter, aren't I? So then W is going to be the weight in grams, which is this one, 11.9. And my area is going to be this one, okay, in square meters. So that's 0.06237. Okay, so we're going to divide that by that. So 11.9 divided by 0.06237, and that comes out to be 190.78, which I'm going to round up. I think we're going to round off to 3 significant figures, so which makes that 191 GSM. Okay, and that's my answer, 191. Question 6. The area of this rectangle can be written as ax squared plus bx minus 10. Okay, so it's a quadratic equation, isn't it? And you can see I'm going to get that because I'm going to multiply x plus c with 3x plus 2 if I want to find its area, which is definitely going to give me a quadratic. Now we need to find the values of a, b, and c. So what we're going to have to do is we're going to have to multiply those two brackets together and compare it with this original equation we've been given to start with. Okay, so let's take these two. Let's take the x plus c and the 3x plus 2 and multiply them together and see what we get. So what is x plus c times 3x plus 2? Now you can use FOIL on this if you know what you're doing, or 2 eyebrows, a nose and a mouth. Sometimes think of it like that. If you're not so good at these, probably best to do it as a grid. So x and c and 3x and 2. And then we've got space to write all our answers in. We're less likely to forget bits of it if we do it this way. So 3x times x, 3x squared. 2 times x is 2x. 3x times c is 3cx. And then finally c times 2 is 2c. Okay? So then I've got a term in 3x squared, which I'm going to write at the start. Look, 3x squared. And then I've got 2 terms in x here, so I'm going to have to combine these together, aren't I? So it's going to be plus 3cx plus 2x, and then I've got a single term in, well, there's the constant term on the end, but it's got a c in it at the moment, plus 2c. Actually, I'm just going to shimmy this along a bit because I want to compare it with the other one now. So now I've got this expression, I can compare it with what we had to start with, this ax squared plus bx minus 10 business. So that's equal to ax squared plus bx minus 10. Comparing coefficients, if we compare the coefficients of x squared, now on the left hand side our coefficient of x squared has got a 3 in it, and on the right hand side it's got an a. Now if these two things are the same thing, then those two things need to be the same as well then, don't they? So this is telling me that 3 on the left must be equal to the a on the right. Okay, in other words, 3 is equal to a, so that is my value of a down there. Okay, so that's the coefficient of x squared. Now if we do the same thing, so compare the coefficients of x next, then on the left we've got 2 things that contribute to the coefficient of x on the left. I've got the 3c here and the 2 here, so actually I've got 3c plus 2 on the left. Those 2 things would add together to give you the coefficient of x on the left, and on the right we just got the single b, so those 2 things must be equal to b. Now I don't know what c is yet, and I don't know what b is yet, so I've got an equation in 2 unknowns there at the moment. So hopefully the last one, so instead of comparing coefficients this time I'm going to compare constants. And then comparing constants, the constants on the end, on the left I've got 2c as my constant, 2c, and that must be equal to the constant on the right, the minus 10. So if 2c is minus 10, then c is going to be minus 10 divided by 2. It's minus 5 then, isn't it? So c is minus 5. And if c is minus 5, then b is going to be 3 lots of minus 5 plus 2. What's that then? Minus 15 plus 2. Isn't that minus 13? Minus 13. So then b is going to be minus 13. So a is 3, b is minus 13, c is minus 5. Question 9. A large box of chocolates contains dark milk and white chocolates. When Riley opens the box, the ratio of dark to milk to white chocolates is in the ratio of 3 to 4 to is in the ratio of 3 to 2 to 4. Riley's family eats 6 of the dark chocolates, none of the milk chocolates, and all of the white chocolates. The ratio of dark to milk chocolates is now 9 to 8. How many white chocolates did Riley's family eat? Right, let's start with this ratio of 3 to 2 to 4. 3 to 2 to 4. Then after we've nommed all the white ones and some of the dark ones, it becomes 9 to 8. Okay, so these are not very easily comparable yet because these numbers are different, aren't they? Now I know that the number of milk chocolates, dark milk, white, is unchanged. So if I just take that 3 to 2 to 4 and I times it up by a factor of 4, it will match then with the 8 I've got in the 9 to 8 ratio below, won't it? So that would be 12 to 8 to 16. Okay, so they kind of match up, don't they? So then we can see that all of those got eaten, and like 3 shares of those got eaten, didn't they, from there to there, and then the number of milk chocolates stayed the same. So those 3 shares that got eaten were worth 6 chocolates. So 3 shares equals 6 chocolates. In other words, 1 share is equal to 2 chocolates. Okay, so our ratio of 12 to 8 to 16, and then if I times all that by 2, I'm going to get 24 to 16 to 32. So that must be like the original state of the chocolate box before anyone started munching on them. So that means that there must have been 32 white chocolates in there before the family got their mitts on them. And so that's my answer then. It's going to be 32 white chocolates. Question 10a. X and y are related by the equation xy equals 36. Tick the correct statement. Y is directly proportional to x, y is inversely proportional to x, y is not proportional to x. Right, well if I rearrange it so it's y is equal to rather than xy is equal to, by dividing both sides by x, I'm going to get y equals 36 over x, which is, you know, a constant divided by x. So that means that y must be in proportion with 1 over x. Okay, so it is inversely proportional to x, it's that one there. Y is inversely proportional to x to the power of 4. Y is 2.5 when x is 2. Find a formula linking x and y. So I'm going to write that down as y is proportional to 1 over x to the power of 4 then. And then this little symbol in here, in this little fishy symbol, is the symbol of proportionality. Once I put that in, I can then replace it with equals k lots of the same thing. So y equals k over x to the power of 4. And they give us a handy pair of values that go together here, and I can use those then to evaluate what k is. So I can say when y is equal to 2.5, then x is going to be equal to 2. And subbing those two things in then, I'm going to get 2.5 is equal to k lots of 2 to the power of 4. Okay? So then 2 to the power of 4 is what? 2, 4, 8, 16. And 16 times 2.5 then. 16 times 2.5. That's 40. So that's going to give me k is equal to 40. And then so the complete equation then is y is equal to k, which we just found to be 40, divided by x to the power of 4. And that's the equation that links y and x. Question 11. The diagram shows a cone and a cube. The cone has radius 8 centimeters and height 10 centimeters. The volume of the cone is equal to the volume of the cube. Work out the length of one side of the cube. The volume V of a cone with radius r and height h is V equals 1/3 of pi r squared h. Okay, so we've been given the formula for the cone. You should probably know the formula for the volume of a cube. It's just L cubed, where L is the length of one side. So we should be able to sort this out, shouldn't we? Okay, so what we've been given. We've given the cone radius is 8 and the height is 10. Radius is 8, the height is 10. That's also on the diagram there, look, 10 and 8. So then the volume of the cone, that's equal to, what's that? 1/3 of pi r squared h. So 1/3 times pi times r, which you know is 8 squared, times h, which you know is 10. Okay, so 8 squared is 64, times 10 is 640. That's going to be 640 pi over 3. Now I'm just going to leave it like that for now because, well, it's an exact form. If I could type it into the calculator and get a decimal, but I'd be rounding it off and then I'm not quite done yet. So it's better to retain accuracy and leave it in an exact form. So then the volume of the cuboid is going to be then, well, we know the volume of a cuboid is just L cubed, where L is one of the sides, and we know it's going to be equal to the same as the other one, the cone, so it's going to be equal to 640 pi over 3. So then L is going to be the cube root of 640 pi over 3. So we need to work that out now from the calculator. So let me write my 3 very neat there. Let's just do that again. So the cube root of 640 pi over 3, so typing that into the calculator carefully. The cube root of 640 lots of pi divided by 3. Now I make that 8.75. Question 12. A cafe owner recorded information about customer orders for coffee. They recorded whether the customer asked for milk and whether the customer asked for sugar. The results are shown in this Venn diagram. So we've got a milk circle and a sugar circle. You can see there's a bit of an overlap in between. One of the customers is chosen at random. Find the probability that the customer asked for sugar. And we should know that probability is equal to successful outcomes divided by total outcomes. So the probability then that the person selected at random has sugar is successful outcomes. So how many people are in the sugar set? It's all the people in here, isn't it? So it's going to be that 11 and 18 added together. 11 plus 18 is 29. So it's going to be 29 over, then it's going to be divided by everybody, isn't it? So that's my 29, and then everybody is everybody inside the Venn diagram. Okay, and everybody inside the Venn diagram is all of those numbers added together. 25 plus 11 plus 18 plus 16. What's that then? 25 plus 11 plus 18 plus 16. Good idea to always show your working out. You get credit for it if you then mess it up. 25 plus 11 plus 18 plus 16. That comes to 70. So 70 customers. So it's 29 over 70 then. Okay, so that was the number in total in the box. So 29 over 70. Now it says one of the customers is chosen at random. Find the probability that the customer asked for sugar given that they asked for milk. Okay, so we want the probability that they asked for sugar given that they asked for milk. Now this second part here, this slash and then the milk, that means that you're not picking from everybody anymore. We're not picking from the blue rectangle. We're just picking from the people within the milk group. So we're picking from within here. So within there, look, I've got 25 plus 11. I've got 36 people to pick from. They're the number of people who had milk or asked for milk. And from within that green circle, how many then asked for sugar? Well, it's going to be these 11. These 11 within the green circle. So it's going to be 11 over 36 then. Okay, so the probability that they asked for sugar given that they've asked for milk is 11 over 36. 11 over 36. Question 13a, the graph of y equals 3 to the power of x is sketched below. On the same axes, sketch the graph of y is equal to 2 to the power of x. Okay, so this is an exponential curve. Exponential curves always pass through the axes at the same place, and that's because any number raised to the power 0 is 1. So 3 to the power 0 is 1, 2 to the power 0 is 1. So I know that my graph y equals 2 to the power of x is going to pass through the y-axis at exactly the same place as the other one does. Now, given that the base is 2 rather than 3, that would indicate that the graph is not going to climb quite as steeply and as quickly as the other one in the positive section of the graph, but it's also not going to taper away quite so much in the negative part of the graph. So what we're going to get is a graph that is slightly above the original curve for the negative values of x and slightly below the curve for the positive values of x, like that. Kind of petered out a bit there. Let's just put that in. So a graph that looks like that. So the key points to get the 3 marks is going to have to be going through that axes at the same point as the original curve. It needs to be above the curve in this section, and it needs to be below the curve in that section. If you've done those 3 things, you're going to get the 3 marks for this sketch. Part B says Charlie sketches this graph. Charlie says the equation of my graph is y equals sine x. Explain how you know that Charlie is not correct. Well, he's not correct because sine x starts at 0, and then sine 90 is already up at 1, isn't it? So sine x is actually looks like this. Okay, it's kind of like the opposite or reflection of the graph that I've got. Okay, so how can I say that in words? The equation of my graph is y equals sine x. Explain how you know that Charlie is not correct. Well, I know because I know that y equals sine x is positive for x lying between 0 and 90. I definitely know that. That's one reason. Now, as for writing down a possible equation for Charlie's graph, we already noted that his graph is a reflection of y equals sine x. And if you think about the transformations of curves, if you want to reflect something in the x-axis, you just put a minus sign in front of the function. So I think I could say that Charlie's graph was y is equal to minus sine x, because when you stick a minus sign in front of a function, you're going to flip it in the x-axis, which is pretty much what I've got there. So I'm going to write down y equals minus sine x. There are actually other possibilities, but I only asked for one, and that's the simplest way to do it. Question 14, here is a right angled triangle. The area of the triangle is 100 square centimeters, correct to the nearest 10 centimeters. The length and base of the triangle is 8 centimeters, correct to the nearest centimeter. Calculate the largest possible height of the triangle. Okay, so we've got a limits of accuracy question here. I know that the area is equal to 100, but that's only correct to the nearest 10 centimeters. Now, if you imagine a scale which is going up in tens, then the next number up on this scale would be 110, and the one before it on this scale would be 90, wouldn't it? Going up in tens, 90, 100, 110. Now, which values round to 100? They're going to be the ones that are halfway between those values or closer to 100, so that region there. So what is halfway between 90 and 100? That's 95. So anything above 95 and below halfway between 100 and 110, what's that, 105, they're going to round to 100. Now obviously 105 actually rounds up to 110, but it's still the boundary and we still use it as the upper bound. Okay, and then so what we've got for the other one, we've got length. We know that that's equal to 8 to the nearest centimeter. So length is, again, I'm going to do the same thing. I'm going to draw a scale, I'm going to write 8 on it, and if it's the nearest centimeter, I'm going to go 1 centimeter up, 1 centimeter down, and I'm going to consider what numbers round then to 7. I think these little sketches are quite helpful, don't take long to do. just to help you visualize these sorts of questions. So halfway between 7 and 8 is 7.5, and halfway between 8 and 9 is 8.5. Right, what we want to do is then work out the height. So I know for the area of a triangle, area is base times height over 2, isn't it? Okay, so how if I want to rearrange that for height, then times in both sides by 2, I'm going to get 2a is equal to b times h, and then dividing through by b, I'm going to get h equals 2a over b. So if h is equal to 2a over b, and I want the height to be as large as possible, which values should I pick? Should I pick the upper bound and the lower bound of the area, or the length? Well, if I think about it, it's a fraction, and it's got a on the top and b on the bottom. Now, if you want the fraction to be as big as you like, if you want it to be, then you're going to pick the biggest numerator that you can possibly get and the smallest denominator that you can possibly get, because the smaller the denominator, the bigger the fraction, isn't it? Because, you know, a half is bigger than a quarter. So the smaller number on the bottom you can get is going to be the biggest fraction, and the biggest numerator you can get is going to be the biggest fraction. So I'm going to pick the largest area, because that's on the top, it's the numerator, and I'm going to pick the smallest base, or length. I wrote length, but I've written base down there. Okay, so it's that one there, isn't it? That's the one I mean for that one. So I'm going to pick 7.5 for the base, and I'm going to pick 105 for the area. So that's 2 lots of 105 divided by b, which is 7.5. Then what's that then? So typing that into the calculator, 2 times 105 divided by 7.5, and that comes out to be 28. So h equals 28 is the solution. Question 15a. Sasha and Taylor are asked to find how many solutions the equation 5 lots of x plus 2 all squared equals 45 has. Here is Sasha's answer. So Sasha said divide both sides by 5, square root must be equal to 1, there is one solution. And Taylor said divide by 5, he square rooted but got 2 solutions, 3 and minus 3, giving him 2 solutions. So I think Taylor is correct, isn't it? Because when you square root a number, which is what's happening from this step to this step, we're square rooting, aren't we? And when you square root a number, there are actually 2 solutions. There's going to be a plus or a minus. Now, Taylor has caught that. He's got his 2 solutions here and here. And here. Giving him his 2 solutions. So I'm going to say that Taylor is correct, because when he square rooted, he remembered there is a positive and negative solution. Part B says solve this equation algebraically. Give your answer correct to 2 decimal places. You must show your working. Okay, so because it's telling me I need to do it correct to 2 decimal places, I'm pretty sure then it's not going to factorize. I'm going to have to use the formula to do this. So the quadratic formula says x is minus b plus or minus the square root of b squared minus 4ac all over 2a. Now I believe this is still on the formula sheet at the moment, although it wouldn't hurt you to remember it like I do there. Speed you up rather than have to go and run away and look at stuff up all the time. So I remembered it. Now, in order to use the formula, I just need to pull out my values of a, b and c. A is the coefficient of x squared, it's going to be 1, I've got 1x squared. B is the coefficient of x, which is minus 5, I've got minus 5x. C is the constant on the end, I've got 3. Okay, so A is 1, B is minus 5, C is 3. Sub in those values carefully into my quadratic formula. Minus b, I usually sub in brackets because it helps deal with all the positive and negative numbers. So minus 5 plus or minus the square root of b squared, minus 5 squared, minus 4 lots of a, which is 1, times c, which is 3, all divided by 2 lots of 1. Okay. Now you can just bung it straight into the calculator at this stage, but I find it's easier to simplify it using your big brain. I'm quite good at simple arithmetic. I'm not always quite so good at typing things into the calculator, so for me I make less mistakes with working stuff out than typing, so I'm going to go and simplify it as much as possible before I type it in. So minus 5, that's 5, plus or minus, I've got negative 5 squared, that's going to be positive 25, minus 4 times 1 times 3, that's 12, isn't it? All over 2, well, lots of 1, which is just 2. So almost there, just going to finish it off a little bit. So that's 5 plus or minus, what's 25 minus 12? That's 13, isn't it? So plus or minus root 13 over 2. Now I've got it into that form, it's just a matter of typing it into your calculator twice, once with a plus sign and once with the minus sign. Okay, so I'm going to type in the fraction key, and then I'm going to write 5 plus root 13 on the top, and then I'm going to divide it by 2 on the bottom like that. So the positive solution, that's given me 4.30 and change, which I'm going to round off to 4.30. Rather than typing the whole thing back in again, I'm just going to use the back key on my calculator. I'm going to delete the plus and I'm going to put in a minus. So that's going to be minus root 13. And that comes out to be 0.697, which is going to round off to 0.70 then, isn't it, to 2 decimal places. So there are my two solutions then, 4.30 and 0.70. Question 16. The graph of y equals x to the power 5 minus 70x minus 150 is sketched below. The root of the equation x to the power 5 minus 70x minus 150 equals 0 is equal to p. Show that the value of p lies between 3 and 4. And then we need to go on and find a smaller interval that contains the solution or the value of p. Okay, now this is actually a trial and improvement question disguised as a kind of a graphy thing. So what we need to do with these questions is we need to make a little bit of a table. We need to work out the value of our function x to the power 5 minus 70x minus 150 for various values, and then see if they are positive or negative. In other words, they lie above or below the axes. Okay, we've been asked to show that it lies between 3 and 4 to start with, and then to find a smaller interval that it lies in between. So I'm going to do both those two steps at once using the table function on my calculator. I'm going to go into the table mode, and once we're in table mode, I need to then put the range of the values into my function and then the function itself. And I do that by, on the new calculator, by pressing the option key at the end over here. So pressing the option key and then going to define f of x. I'm going to type in the function that they've given me, and that is x to the power 5 minus 70x minus 150. So I'm going to type that carefully in. So x to the power of 5 minus 70x minus 150. Okay, so once I've got the function typed in, I then need to put the range in. So I'm going to press the option key again, and I'm going to go to the table range. Now my table range, I'm going to start at the lower value they asked me to test, which is 3. So I'm going to start at 3. I'm going to end at the upper value they gave me, which was 4. Now for the first part of the question I only need 3 and 4, but I know for the next part I need to go to a smaller interval. So I'm going to type in that the step is 0.1. So it will find all the values between 3 and 4 and all of like the values from in between, like 3.1, 3.2, 3.3, 3.4 and so on. So when I press enter now, I'm going to get the table appear for all the values from 3 up to 4 going in increments of 0.1 and the values that go in between. Now the first value in my table, when x is 3, I can see it's given me the solution that f of x equal to minus 117. So I'm going to write that in my table. When x is equal to 3, then my f of x value is going to be minus 117, which is clearly negative. Okay? And then if I go all the way down to the other end of the table, you can see that my value for 4, that is 594. So when x is 4, my answer is 594, and that is definitely very positive. Okay, so between 3 and 4, it's switched from being negative to positive, and so it must have passed through the x-axis. It must have been 0 at some point in between. So I'm just going to write that down. It has changed from negative to positive between 3 and 4, so P must lie in between. Okay, so I've done the first part of the question. I've worked out the value of 3 and 4. I've seen one is negative, one is positive, and so that the solution must lie in between. So now I need to go and find 2 other increments that lies between. Now, because I've already worked it out on my calculator, I just need to scroll through my list and find the point where it's switched from negative to positive. So if you can see on the table, at 3.2 it was negative, it was minus 38.4 and a bit, and then at 3.3 it becomes 10. So I can then write that down to a smaller increment by adding those 2 numbers to my table then. So I'm going to write 3.2. At 3.2 it was minus 38.45. Well, I'm going to round it up to 46, I guess. And that is negative. And then for 3.3, it's gone up to 10.35. 10.35, which is positive. So then P then must lie between 3.2 and 3.3. Question 17. Hero invests £2,500 for 2 years in a bank account paying R% per year compound interest. At the end of the 2 years, the amount in the bank account is £2,704. Calculate R. Okay, so in order to do compound interest, you're going to get your final amount is going to be your original amount times your multiplier raised to the number of years or the number of times that you're applying the compound interest. In this case, it's going to be years, isn't it? So my final, I'm told, is 2,704. The final is this one here, 2,704. The original is what was in the bank to start with. That's 2,500. That's equal to 2,500. And then the multiplier, well, that's what we're trying to find. It's the R there, isn't it? So that's going to be my R to the number of years. Well, it's not quite R actually. There's R%, so I'm going to have like 0.R. So maybe I'm just going to leave an M so I don't confuse what my R is. So I'm going to put my multiplier raised to the number of years. Years is 2. Okay, so I'm going to work out the multiplier as a decimal, and then R will be the percentage version of that multiplier. I don't want to confuse my units here, and I don't want to write a construct with R in it over 100 because it's unnecessarily confusing. Okay, so then I know that my multiplier squared then is going to be, if I divide both sides by 2,500, I know that 2,704 over 2,500 is going to be equal to m squared. So I guess if I then square root both sides, I'm going to get m is equal to 2,704 over 2,500. And what's that then? So the root of 2,704 divided by 2,500. That's 1.04. And so m, my multiplier, 1.04, that's as a decimal. So then R, my percentage then, is going to be, well, that's 104%, isn't it? So that is an increase of 4%. So r is equal to 4. Like I say, if I'd put r in there, it wouldn't actually be quite right. I'd have to put r over 100, and yeah, so it's just easier to leave it out until the end. Question 18. A, B, and C are points on the circumference of the circle. Point C and D lie on the tangent to the circle at C. Angle BCD is equal to 45 degrees. Angle ACB is equal to 58 degrees. AB is 8 centimeters. Well, that's interesting. So we've got some length in our circle theorems question here. So find the length of BC. That's what we need to do. So I think it's going to be a mixture then of circle theorems and trigonometry then, isn't it? That's going to be fun. And what do we need to find? So I think because it's a non-right angle triangle, we're going to have to use either the sine rule and the cosine rule. And because we only know one side, it's definitely not going to be the cosine rule, is it? Because the cosine rule requires two sides and an angle to find the side. So it's definitely not the cosine rule. I need the sine rule here, I think. But again, I don't quite know enough info for the sine rule, because the sine rule is about opposite pairs. Now I've got an opposite pair here. Look, I've got the 8 and the 58 degrees. They're opposite pairs that go together. Now if I want to find the length BC, which in the parlance of non-right angle triangles, we label sides as the lowercase version of the letter on the opposite side of that triangle. So that would be side A. So if I want to find side A, I'm going to have to know angle A over here. So I'm going to have to find that angle first before I can then go on and use the sine rule here. Now that's actually not going to be an issue at all, because there is a certain rule in circle theorems called the alternate segment theorem. And that states that the angle between the tangent and a chord drawn at the point of contact, which is there, is equal to the angle subtended in the alternate segment, which is that angle up there then. In other words, that angle up there, A, is the same as that 45 degrees down there. Okay? So I'm just going to write that that's 45. And I'm going to write that down in words. It's not a proof question, but I'm going to write it down anyway. So using alternate segment theorem, then I know that CAB, angle CAB, is equal to angle BCD. And that's equal to 45 degrees. So now I know that that's 45 degrees. Now I can use the sine rule, can't I? Because I've got opposite pairs now. I want to find the side, so I'm going to write the version of sine rule with the thing that I want to find on the top, and that's a side in this case. So I want side A. I actually know side C if you think about it, because this is the side opposite angle C. So I'm going to write the bit of the sine rule that I need, and that is A over sine A is equal to C over sine C. Now the sine rule is made up of 3 parts, but you only ever use 2 parts of it, and you use whichever 2 parts you need and whichever way up you need them to be. Okay, because you can write it as sine A over A is equal to sine C over C, or the other way up. So because I want to find A, I've put A at the top, and because I've got side C, I'm going to have the A part and the C part and not bother with the B part. Okay, so now I've formed the sine rule version I'm going to use. It's just a matter of plugging all the numbers in now, isn't it? So A is what I'm trying to find, so that's going to just stay being A. Sine A, what is angle A? Is 45, isn't it? So that's sine 45. So A over sine 45 is equal to side C, which is 8, divided by sine C, which is the sine of 58. Rearranging for A, just cross multiplying that sine 45 down there. I'm just going to times it, and it will appear over there on the opposite side, isn't it? So A is going to be 8 sine 45 over sine 58. Okay, so tappity-tap that into the old calculator. 8 sine 45 divided by sine 58. Apparently that is 6.67. 6.67. That's my final answer then, 6.67. Advertisement break. Looking for a maths tutor to help you through your GCSE, A-level or IB exams? Then why not check out Mr. Tompkins Tutors at mr.tompkins.online/tutors. Mr. Tompkins Tutors offers personalised one-to-one quality tuition online via Teams direct to your home. Tuition is delivered by myself and a team of first-rate teachers who I've personally known and worked with for years. All have qualified teacher status in the UK and a recent full DBS disclosure, so you can be confident that you're in good hands. To find out more and request a trial lesson, simply visit the website linked below and complete the online form, and we'll be in touch with you soon. Until then, let's get back to the maths. Question 19. A fitness centre records how long each customer spends in the gym. This is the cumulative frequency. Look at that, it's in bold. Cumulative frequency table is literally shouting itself at you there. So this cumulative frequency table summarises the results. Okay. Calculate an estimate of the mean time the customers spend in the gym. You must show your work in. You may use the table above to present your work. Okay, so we've got to move from a cumulative frequency table back into a frequency table and then use that frequency table to work out the mean, or an estimate of the mean, because it's group data here, isn't it? So I'm going to have time up here in my first column. I'm going to use this grid to help me. I'm going to start with time in t minutes. But rather than having less than or equal to 10, I'm going to have t lie in between 0 and 10 like that. Okay, and then my next group is going to be t lies between 10 and 20. T lies between 20 and 30. T lies between 30 and 40. T lies between 40 and 50. And t lies between 50 and 60. Okay, so that's my t minutes. Next I'm going to work out frequency. Well, actually I might just do mid values next, because I know what I'm going to be doing. So what's mid t? Mid t is going to be my halfway values between those limits, aren't I? When I work out an estimated mean with group data, I have to use the mid value of each range. So halfway between 0 and 10 is 5, halfway between 10 and 20 is 15, halfway between 20 and 30 is 25, and so on. I'm going to get 35, 45, and 55 as my midpoints. Next up, I'm going to need frequency. Now, if I've got t less than equal to 10 is equal to 6, then I must have had 6 people in that first category between 0 and 10. But if I've got t is less than equal to 20 is 24, that includes the 6 that I've already had between 0 and 10. So 24 take away 6, that's going to be 18. So that these two numbers added together gives you the 24, working backwards from the cumulative frequency into frequency. So then the 6 and the 18 and whatever goes into the next box is going to be 35. So the difference between 35 and 24 is 11. So that next group there must be 11. The difference between 35 and 48 is 13. The difference between 48 and 16 is 12. And the difference between 60 and 74 is 14. So they're all my frequencies. So what does that add up to? How many people have I got altogether? Well, it should just be the same as that number down there. It shouldn't really need to add it up, because it's going to be equal to the last cumulative frequency. You might want to just double check that if you want to, but I'm pretty sure that's correct. And then finally, I need to know ft. Ft, the frequency times the t value, and we're going to be using the mid value for t. So we're going to multiply each of these together, and then I'm going to add them all up. Okay, so just quickly zipping that through with the calculator. 5 times 6, that's 30. 15 times 18, that's 270. 25 times 11, that's 275. 13 times 35, That's 455. 45 times 12, 540. And 55 times 14, that's 770. Right, and then we need the sum of that then. So that 74 is sigma f, stop sniggering, and this one is sigma ft. Okay, so the sum of the frequencies, that's what sigma means. It doesn't mean some weird thing that you guys have found on TikTok. It's actually a Greek letter. And so sigma ft means the sum of all your frequency times your times. So we're going to add all those together. That's 30 plus 270 plus 275 plus 455 plus 540 plus 770. So that's 2,340. 2,340. Okay, so then my estimated mean now it's estimated and not just a normal mean because I've rounded off, haven't I? Well, I've estimated each value in the table to be at the mid value of its range, and that's why it's estimated, not exact. So then the estimated mean is going to be sigma ft, the sum of the frequencies times the times, divided by sigma f, the sum of the frequencies. And that's going to be 2340 over 74. What's that then? 2340 divided by 74. That is 31 and a bit. 31.6. I think I'm going to round it off to 31.6 minutes. Question 20. This shape is formed from a rectangle and two sectors of circles. Points A, B, and C lie on the straight line. Angle CBD is 35. D is 5t and EF is 2t. Now, before you do anything, just check all the information on in the question that's in written form is on the diagram. So angle CBD is 35. It's there. Look. DE is 5t, whereas that's over there, and EF is 2t. That's also on my diagram. So everything's on there. Always good just to double check though, because sometimes it isn't. Part A says explain why BC equals 2t. Give reasons for each step of your explanation. Okay, well, BC, where's BC? BC is that length there. Now, BC is the radius of that sector BCD there, isn't it? Okay, so it's a radius of that sector, but also this is also a radius of that sector, isn't it? Because from the B is the center of the circle then, if that's a sector. So those two lengths have to be the same, and that BD is they're going to be the same as this side here, isn't it? Because they're opposite sides of that rectangle. So I need to put that down in words. I'm going to say that BD equals EF, which is equal to 2t, because they are opposite sides of a rectangle. And I can say that BC is equal to BD, which is equal to 2t, because they are both radii, it's the plural of radius, both radii of sector CBD. Okay, so they're my 2 marks. So just stringing those two thoughts together. And then part B says show the perimeter of the shape is 23 over 12 pi t plus 14t. Okay, so quite a complicated perimeter. It's got BC I've already marked. It's the radius of that sector, which I know is 2t. I found it earlier. Let's write that in. Okay, then I've got this side here, which is going to actually be the same as this side, which is going to be the same as this side, isn't it? It's going to be 5t. That's going to be 5t for the same reasons that BC was 2t. And then so what we really need to do is define those two arc lengths, don't I? I need to find arc length CD and arc length AF. All the others I seem to know now. So let's find arc CD first. So that is arc CD. This part here, look, that's the arc of this sector, which has got a radius of 2t and an angle at the center of 35. So it's going to be the angle at the center, 35, over 360 times. So an arc is a fraction of a circumference, and the formula for a circumference of a circle is 2 pi r. So 2 times pi times the radius, in which in this case it's 2t then, isn't it? Okay, just combining all those numbers in the numerator. 35 times 2 times 2, double 35 is 70, and double it again is 140. So that gives me 140 over 360 lots of pi t. Okay, so that's arc CD. What about arc AF? Well, we need the angle at the center of AF first. What's the angle there? Now remember, angles on a straight line sum to 180, and I know that that one there is 90. So then this angle here then is going to be 180 degrees minus the other two then, isn't it? It's going to be minus the 90 and the 35. So 90 and 35 together is 125. Take it away from 180. That gives me a 55 degree angle. So that one there is a 55 degree angle. So now we're ready to work out the arc length of AF. Now we know that angle. So it's going to be equal to the angle at the center, which is 55, divided by 360, because there's 360 degrees in a turn. And then multiply again by the circumference formula of a circle, which is 2 pi times the radius. And the radius of this one is 5t, isn't it? So again, just collecting up all those numbers in the numerator. 2 times 5 is 10. 10 times 55 is 550. So that's 550 over 360 lots of pi t. And then so the perimeter is going to be all those sides added together then. So I've got my two arcs, which are 140 over 360 pi t, plus the other one, which was 550 over 360 pi t, plus we've got two green lines and two blue lines, haven't we? So we've got plus 5t plus 2t plus 5t plus 2t. Okay? So this bit here is the pink bit, and then this is the purple bit down here, which we calculated here, which I've written here, and then I've got two green lines and I've got two blue lines. That's where my perimeter comes from, all the bits. So then adding that all up then, so the 5t and the 2t and the 5t and the 2t, that just sums to 14t, doesn't it? That's the easy bit. And then adding those two fractions together, notice they got the same bit at the end, pi t. So I've got 550 over 360 and 140 over 360. So if I add the numerators together there, that's going to give me, what, 690 over 360? So I'm going to get 690 over 360 lots of pi t plus the 14t. Now we're almost there. Just that 690 over 360, that can simplify. So just typing that into your calculator to simplify it. 690 over 360, what does that come out to be? And that's 1 and 11/12, or you could rewrite that as 23 over 12, couldn't you? So that's equal to 23 over 12 lots of pi t plus 14t. Now, luckily, that's exactly what we were meant to get, 23 over 12 lots of pi t plus 14t. So we seem to have done it. It's correct. Question 21, simplify fully x cubed plus 8x squared plus 15x all over x cubed minus 9x. Now, on first glance, it looks like we've got some cubic expressions here, and we need to, factorize and cancel factors, but we don't know how to factorize cubic, so you haven't been taught it. You only know how to factorize quadratics. But luckily, on this top line, look, everything has got an x in it. X, x, x. So that means we could factorize out an x out of all of them to start with. So that would be x lots of x squared plus 8x plus 15. And now we've got x times a quadratic. And we can do the same thing on the bottom as well, look, because I've got x and x in both of those. So factorizing out an x as well. That's going to be x lots of x squared minus 9. Okay. Now I'm just going to cancel those x's straight away, and I'm going to just forget about those. They're gone. So now I'm left with a quadratic on the top and, well, it's a quadratic on the bottom, but it's a special sort, isn't it? It's a dots. It's a difference of 2 squares. So I know how to factorize both of those, luckily. First one is the top one is going to go into 2 brackets. I'm looking at that number on the end, that 15, and I'm thinking about factor pairs of 15. What are the factor pairs of 15? I've got 1 and 15, 3 and 5. Not a lot of choice. Which one of those pairs adds up to 8? Need 8 in the middle there. Look, it's going to be that pair there. It's going to be the 3 and the 5 that add up to 8. So I'm going to have x plus 3 on the top and x plus 5 in the second bracket. Right, and then underneath I've got a difference of 2 squares, which I know also factorizes into 2 brackets. X squared, the root of x squared is x. It's going to go there and there. The root of 9 is 3. It's going to go there and there. I'm going to have 1 plus, 1 minus. So x plus 3, x minus 3. And can you see I've got an x plus 3 on both the numerator and the denominator? I mean, we can now cancel those as well. And that's going to leave us then with x plus 5 over x minus 3. Now, we're not going to get any more simple than that. That's the answer. That's probably the easiest 5 marks on the paper there. X minus 3, like that. X plus 5, x minus 3. It's always good when the last question is actually quite straightforward.
Mr. T, he's the best. Helps you